Hello, and today's purpose of the day is I can simplify rational expressions and find their x-intercepts. All right, we are on 11.3, Simplifying Rational Expressions Continued. We have two goals that we're going to accomplish today. Goal 3, so continuing again from yesterday's lesson, simplify rational expressions with factoring. And goal 4 is find the zeros or x-intercepts of rational functions. So question 1 says, simplify and state the excluded values for x. So on the right-hand side are the steps that we need to follow. Step number 1 is factor both the top and bottom of the fraction, so both the numerator and denominator. So let's take a look more closely at number 1. So again, step 1 says factor both the top and the bottom, so numerator and denominator. So on the top of my fraction, 4x plus 16, I'm going to factor out a 4 and then undistribute and get x plus 4. Right? So again, taking out the GCF of 4. Now if I factor the denominator, I need to actually use the diamond method and find factors of negative 36 that when added together give me negative 5. That would be negative 9 and positive 4. So I would write here x minus 9 times the quantity x plus 4. So that's step 1 complete. Factor both the top and the bottom. Now let's look at step 2. Identify the excluded values. So again, we identify excluded values by setting the denominator equal to 0. So I'm going to set x minus 9 times x plus 4 equal to 0. So my two excluded values, and I'll write EV for excluded values, would be positive 9 and negative 4. So that's step 2, identify excluded values. And step 3 then says simplify, because we want to simplify this rational expression. And here, if we look at from step 1, what we've factored, we can actually cancel out some terms here. So I can cancel out x plus 4 over x plus 4, because that would be, like 4 over 4, which would cancel out to 1, but it's x plus 4 over x plus 4. So then my simplified version would be 4 over x minus 9. So I was looking for two things here. One, the excluded values, which we've figured out, and the simplified version of this rational expression, which we also have figured out. Okay, let's take a look at two more examples here. So if you look at this top example, I'm going to factor both the numerator and denominator. So factors of 21, that when added together give me 10, would be 7 and 3. So I get x plus 3 over x plus 7 and x plus 3. So that's step 1. Step 2, identify the excluded values. So here, excluded values are negative 7 and negative 3. And then I also have to simplify. So I'll simplify the x plus 3 over x plus 3. And my simplified answer would be 1 over x plus 7. Okay, let's look at one more here. So I see 25 minus x squared over 8x minus 40. So if I rewrite my numerator so that I have my variable written first, I get negative x squared plus 25 over 8x minus 40. Now I'm going to factor both the numerator and denominator. So if I factor negative x squared plus 25, that is going to turn into a negative x times x, and then plus 5 and plus 5. Really, that's like the difference of two squares. But here I flip-flopped where I put my x squared and 25, so that's why I need to take into account that the x squared is actually negative. And then that is going to be over, I can factor out either an 8 or a negative 8. And here, just because I see that I have a negative x plus 5, I am actually going to take out a negative 8 and then undistribute, and negative 8 to get to positive 8x would be a negative x. Negative 8 to get to a negative 40 would be a plus 5. And now I could have actually factored out an 8, but I would have had an additive inverse that I would then have had to take out a negative with. So I just actually did that in one step because I could see what was going to happen. And now let's find the excluded values. So by setting the denominator equal to 0 here, and so I'm just going to set the negative x plus 5 equal to 0 because this negative 8 here does not have a variable, so that won't help me at all. So I'm going to subtract 5 and get negative x equals negative 5, divide by a negative, so x equals positive 5. So my excluded value is 5, but now I need to look at my simplified answer, so I can actually take out the negative x plus 5 over the negative x plus 5, and my simplified answer would be x plus 5 over negative 8. Now let's look at finding the zeros, also known as x-intercepts. So once simplified, okay, so we need to simplify our rational expression first, or our rational function. The rational function has zeros at the values that make the numerator equal to 0. So now it is a little bit different because we want to set the numerator equal to 0, not the denominator. So again, x-intercepts would be setting the numerator equal to 0, but excluded values is when we set the denominator equal to 0. So let's take a look here at this first example. So f of x equals x squared plus 8x plus 7. So the first step here is we need to factor both the top and the bottom of our fraction, so both the numerator and denominator. So I need to find factors of 7 that when added together give me 8. So that will be 7 and 1. So x plus 7 times x plus 1 all over x plus 1. The denominator is already in simplified form. Now we need to simplify second, and then we'll set our numerator equal to 0. So I'm going to simplify by canceling out the x plus 1's. So our simplified version of this rational function is x plus 7. But now let's find our x-intercepts. So now I need to set my numerator equal to 0, and in my simplified expression, x plus 7 is in my numerator, so I will just say x plus 7 equals 0, so x would equal negative 7, so my x-intercept would be negative 7, comma 0, again, ordered pair form. So these are the two pieces of information we are looking for, the simplified version of our rational function and the x-intercept. Okay, let's look at a few more examples for finding the zeros and getting our simplified version of our rational function. So let's look at the first one, f of x equals x squared plus 2x minus 15. So factors of negative 15 that when added together give me 2 are x plus 5 and x minus 3 all over x plus 1. And that actually is our simplified version because I can't factor anything out. And then our x-intercepts would be setting the numerator equal to 0. So if I set x plus 5 equal to 0, I would get negative 5. And if I set x minus 3 equal to 0, I would get positive 3. So that's number 1. Let's look at the second one. F of x equals x squared plus 6x plus 8 over x squared plus x minus 2. Again, step 1 is to factor. So factors of 8 that when added together give me 6 are 4 and 2. And then on the denominator, factors of negative 2 that when added together give me 1 are positive 2 and negative 1. Okay, so now we need to simplify before we find the x-intercepts. So I will cross out anything that can cancel out. My x plus 2's. So my simplified version of this rational function would be x plus 4 over x minus 1, and then my x-intercept here would be setting the numerator equal to 0. So if I set x plus 4 equal to 0, I would get negative 4. Thank you for listening. Please check Google Classroom for more information. Have a great day. Bye.